Now I'm going to explain the evolution and design of stub axles, or steering knuckles as some people prefer to call them. This is an original 66 Mustang stub axle. Its manufacturing process was the best in its day. Forged steel. You can tell it's a forging. There's a joiner line where the two forced clamps hammer this metal together. That produces a dense material that's both durable and extremely strong, even though you use a low-grade material. That continued on through to the 80s, and then we had a substantial shift. A lot of steering components and suspension components were now cast steel. A number of different manufacturing processes have been adopted for that. This one is a sand casting, and there's also investment casting. The sand cast procedure requires a lot more bulk in certain stressed areas. Also added to that, it needs to be heat treated. Likewise with investment casting. And this is a very durable unit too. This is off of a VT Commodore, otherwise known in the States as a Pontiac GTO. And you'll see some of the commonalities between the RRS components and these as we sort of move through. Now, on these setups, like this one, you'll notice it has a grease cap. Inside there is a series of tapered rollers. The principal load-bearing area is on the inner tapered roller. The outside one is a stabiliser. So most of the weight is carried on the inside tapered roller. Now as you go to a bearing hub, which is this type of setup, you'll notice there's no grease cap. It's a sealed type bearing. Its stub axle is incorporated into the design of the unit. It has a double roller bearing inside it, much larger surface area than this, and as a consequence used with early model rims with their types of offset design. This has about a little more than 20% higher load bearing capacity, which is ideal for big diameter rims with wider tread patterns. Added to that, we've seen a sort of evolution come through. Some of these things, this is out of a Fox body Mustang. Some people adapt this as a suspension system into vintage Mustangs. Whole series of sort of design flaws in doing that. Principally Ackerman angle. You can't get correct steering geometry if you use this and a strut assembly in a vintage Mustang. It's impossible. Mind you, it's quite an economical way of doing it. It's just not the RRS way of doing it. Now, as we move through these things, I'll explain some of the design changes that have happened that affect steering geometry, and most importantly, a little understood area of unsprung weight. And this is a very important thing that has shown a complete evolution of these designs. Because the ideal thing is to keep the wheel assembly that is moving, the unsprung weight, as light as possibly can be and as durable at the same time. And the idea is, the lighter it is, the easier it's going to react with the road, follow the contours of the road and produce better grip. So, on these, it's a little bit deceptive. By the time you put a bearing hub on it, or this type of assembly here, that weight increases dramatically. Once you put this bearing hub on this original steel sand cast unit, it's very heavy also. This is heavier yet again by the time you put the bearing hub on it. So these are sort of areas that I've concentrated on in the design and evolution of our products, and we've done a lot of experimentation to produce the most durable and accurate outcome possible. So I'll just show you the differences between these and the RRS design. So you can see the differences clearly between these old designs, even Fox body Mustang stub assembly. This is a Falcon, or the same as 70 to 73 Mustang, and the RRS options. bearing hub or the spindle in 2 different sizes. The advantages, of course, are reduced unsprung weight, more durable, and most importantly, getting the steering geometry right. There's plenty of people trying to sort of make their own sort of stub axle assemblies. I have not seen one yet that has managed to incorporate all of these designs into their system. And the biggest thing that they usually get wrong is the caster angle and steering axis inclination. And then they have to put in patch-up designs to counter that. We get asked this question a lot. Is RRS a race car component or a street car component? Well, the short of that is it has all of the advantages that you would want on a racetrack, but it's principally designed to be used on the street. And the reason being is we've actually made things a little heavier than you would otherwise have on a race car, where you can afford to tap into breakages or you rotate parts around and only have a limited time on the track. On a road car, you don't have that kind of luxury, so you want this to be durable, tough enough that it's going to be able to hit a few curbs without failing, be easy in maintenance, and still deliver the performance of a modern car. So the upshot of this is it is a street unit that can be used on the track. And you get all the best advantages over all of this. It'll still outdo all of these components, hands down, on a track as a direct comparison, and on the street too.